So you can see the screen, right?
Yes, sir.
Okay, let's start. Okay, so we are now towards the later part of the course. We are on the ninth week. So in this week, we mainly will talk about some topics about the aerosols and a bit about starting at the starting we will be talking about the remaining part of the snowball earth and then aerosols and yeah, that's it. I think for this week these two are the two major topics. So last week we have discussed about the snowball earth. So we discussed how the earth was completely covered in snow at approximately 600 to 600 to 700 billion years ago from present, and then it all again returned to the snow-free Earth position, and then the thing has actually never repeated due to a higher intensity of the sun, and also increased value of the carbon dioxide. So, immediately after the snowball Earth, there was an effect which is known as super greenhouse effect. After the Earth was completely covered in snow, let's assume that it was completely covered in snow because there are a few hypotheses which state that Earth was not exactly covered in thick layers of snow, but there was regions near the equator which were ice free. So they call it cerebral Earth, so a thin patch of ice-free Earth on the other regions near the equator, and that was crucial for the living of the organisms. That was the hypothesis. Anyways, just assume that it was mostly covered in snow, and from that positions, the temperatures at one point of time started increasing rapidly, and it completely melted the snow, whatever snow was present on Earth, and the surface temperatures reached up to 40 to 50 degrees Celsius in the tropics. So from the temperatures below zero, sub-zero temperatures, to very high temperatures, even nowadays we cannot expect the average temperature of the tropics to be 40 to 50 degrees Celsius. Maybe it is at most it is 25 to 30 degrees Celsius, whereas the average temperature for Earth is I think 15 degrees Celsius. So why did it occur? Why it experienced a sudden jump in the temperature far more than the normal period? So there are a few hypotheses uh, which for the support of the observations. So the most popular hypothesis is that carbon dioxide was released from the volcanic activities. So the volcanoes always release the carbon dioxide. The volcanoes are always active, and because the carbonate rocks are melted in the mantle layer of the earth due to tectonic activities, which is still active, the carbonate is converted to carbon dioxide from the volcanic activities, and it is a continuous process which continues throughout the time period. It also continued throughout the ice age. So it accumulated. So it was irrespective of the snowball. So what was happening is on the surface was not important to the volcano. It was independent of that. So carbon dioxide was accumulated in the atmosphere in the time, and uh, on one hand the snow was completely covering the earth, and the carbon dioxide was accumulating in the atmosphere. Now at one point of time the carbon dioxide started playing a role in melting the ice. So it is not a linear process. Of course, it is not a linear process that something will slowly happen and this too will be in a perfect slow rhythm. This doesn't happen. So if I go to that picture, let's say the latitude of permanent sea ice, it is at 0 degrees. So you can think of that as a completely snow-covered ice. Then one point of time, the carbon dioxide was the radiative forcing indicates the amount of carbon dioxide, let's say. So it was so high that it suddenly jumped from let's say 10 degrees to 90 degrees. That means completely ice-free state. And it was a very rapid process. And after that, it started melting. I mean, in the meantime, it started melting. And after the melting of the ice, the fraction of the sea was quite increased, and it started dissolving the carbon dioxide in the water because carbon dioxide dissolves quite well in the water. And then the amount of carbon dioxide started decreasing, and then it reached somewhere close to, let's say, 60 degrees north or south in the current position. And it is just continuing. And after that, we have just received small ice edges, but not completely snowball Earth. Okay. So the high amount of carbon dioxide caused strong greenhouse effect, but it was not linear. So it was rapid. And due to the rapidness, the temperatures reached 40 degrees Celsius to 50 degrees Celsius in the tropics. So from very cool condition to very warm condition. It is also called as hot house Earth. One is called snow house, another is called hot house or warm house, like that. And yes, I mean, the procedure involved is the ice albedo feedback because ice has higher albedo compared to water or ocean. So once it started melting, the feedback caused positive effects, or it basically supported the melting of the ice, and it reached higher values compared to the normal conditions. And after the carbon dioxide did the greenhouse effect, all the ice melted, it again started being dissolved into the seawater. So forming carbonic acid and then forming calcium carbonate or magnesium carbonate, this type of compounds. And it is a part of the carbon silicate cycle, which is a regular cycle. And it was finally deposited at the ocean floor. And the cycle continues actually. From the ocean floor, it again reaches the volcanic regions or mantle, and then it again is released into the atmosphere. That cycle continues like that. So this picture, let's say CO2 is dissolved in the water and it forms the calcium carbonate, and the oceanic crust that basically to goes towards the mantle layer of the earth where the temperature is quite high, and these are all also linked to the volcanoes or the vents related to volcanic activities, and due to the high temperature it is again released into the atmosphere. So this is a natural cycle. Now for the fossil fuel, what we are doing is not part of this natural cycle. That's why the increase of the carbon dioxide due to the anthropogenic activities is of a big concern. So, so yeah, so it was important. This event what was important to understand the feedback mechanisms and how the ice age and rapid warming these things occur, and this can also occur in the future. So nothing is very stable. That is a learning from that. And what are the causes? What are the natural causes? What are the natural feedback processes? What is not natural? What is forcing? These things also can be understood in terms of these events of snowball Earth and later the ice-free Earth, or it is also known as the super greenhouse effect because the greenhouse effect was very strong. The pressure of the carbon dioxide was probably 1,000 times of that that is present today. So yeah, that is the cause for this rapid warming or super greenhouse effect. So yeah, you can ask for any doubt for this. Any doubts, please you can ask.
Correct.
Shall I proceed?
Yes.
Okay. Okay, this is just a picture of the indicating the temperatures, actually that indicating the latitude of ice or glaciation. So here neoproterozoic or Tertian or the snowball time, the temperature was so low that the latitude of glaciation was almost 0 degrees. This was the bigger snowball Earth and another snowball Earth which was smaller. After that, it completely melted. So the ice latitude went to 90 degrees, indicating that the Earth was completely ice free after that. And then there were intermediate events in which the ice latitude was 30 degrees or 60 degrees in between, but it never reached the equator. So Earth never became a completely covered in snow after that. And today, I think the latitude is close to 60 degrees. So beyond 60 degrees north or south, we can see permanent ice present on the earth. Though it is again melting due to greenhouse effect, especially in the northern hemisphere, the effect is very much evident. And that's why we should be concerned about those things. This is just a picture of showing the cycle of the carbon and the silicon. So carbon silicon cycle or carbon silicate cycle is a natural part of controlling the carbon dioxide in the atmosphere via the calcium carbonate deposits, which is actually they have shown the arrow in only one direction, but it is actually present in both the directions. So whenever carbon dioxide is excess in the atmosphere, it drives the reverse reaction to form calcium carbonate or magnesium carbonate, this type of compounds. And later this is merged with the mantle, and then they call it metamorphism. So that releases carbon dioxide, and the carbon dioxide is again released in the atmosphere. Okay. So now we will move to the
Actually, I have a question. Like,
yes,
if if the latitude of the ice reaches 30 degree, then there'll be runaway glaciation, right? In yeah, this one.
right,
So it reaches 30 degree in ED Neoproteinozoic,
proterozoic.
right? So why isn't it going into glaciation?
Oh, actually, the problem is we cannot consider a single factor for the glaciation of or the complete snowball Earth. Now,
Okay.
see, at this case, Paleozoic, it also reached 30 degrees latitude. But the first of all, the solar intensity was little increased from that point, and then
Oh,
knows that what phase of Milankovitch cycle it was in. So it is not a single parameter problem that if the earth snow latitude of snow reaches 30 degree, it will be completely snowball earth. It will become completely snowball earth. So it is not a single value problem. There are multiple states, multiple factors. So I don't precisely know the reason for what exactly it didn't reach after 30 degrees, but possible reasons might include that the solar intensity, the solar constant
was
reached a
different.
higher value, first of all. Secondly, it might happen that the position of the continents were not suitable. So the position of the continents, if they are close to the equator, then there is a higher possibility of the what you call is snowball earth. Okay, because if it
Okay.
is close to the equator, then the albedo becomes high. And because see, the sun's ray sun's rays always are perpendicular in the equator, right? Mostly perpendicular.
Yes.
So uh, if if the continents are in the close to the equator, then the albedos due to continents will also be higher, because by default they receive higher solar
Yes.
insolation. So, and yeah, so that is the, I mean, putting a continent in the polar region will not have much change in the albedo. So that might be another reason. Third reason might be that it was in a phase of Milankovitch cycle, such that the Earth was not in a situation for seasonal extreme. So very cold winter or very warm summer, it was not in that phase. This might be the reason. And also it might be possible that the orbit of the Earth was not that elliptical. If it is
Like
circular, then
oblique.
yes, yes. So the possibility is less. So there are many factors. That's why modeling those things are very difficult. Now, if it was only one parameter that, okay, Earth has ice at 30 degrees, then it will eventually reach the snowball Earth is not the solution. Now, currently, whatever solution we are, I mean, whatever state we are in, Earth has lived. Just think of one thing, okay? So we studied in the previous sections, that previous weeks, that there are two stable solutions. One is snowball Earth, another is snow-free Earth. In between whatever
Yes.
in between whatever solution is there is unstable, because
Okay.
you can argue from the simple diagram of that we showed, right? We can go to the diagram.
Yes. Equilibrium. Yes. Yes, I remember.
Let me just check this. So anyways, this type of diagram, okay. So yeah,
Mhm.
so the higher point and the lower points, they are always stable equilibrium. The middle point is in the unstable equilibrium. Middle point denotes some fraction of snow which is between 0 and 100%. So now, yeah, there are different factors due to which still we are having somehow equilibrium solution in the middle, but we don't know whether we will reach the ice-free Earth in the near future or not. Uh, that is of a debate, long discussion. So that is the thing. We cannot just define on a single parameter.
Okay. Thank you.
So, okay, now we will move to the section of aerosols. So, before that, is the answer clear to everyone else? The question Arjun asked, is it clear to the answer? Is the answer clear to everyone else? I hope so. Okay, fine. So now we will just read some property of the aerosols. Just recap. There are some questions associated to aerosols. Now, aerosols are particles which we cannot basically see. These are so small. Now, how they can warm and cool the surface of the earth? That is one question. Now, how does the composition of aerosols vary in India? That is about the geographical study. So we can look into that. And the effects of smaller and larger aerosols on human and also the climate. How it can change the liquid droplet size of the clouds, and how it can change the cloud albedo, cloud lifetime. There are the two very famous aerosols, which are sulfate aerosols and black carbon aerosols. So that is these things we will also discuss. And how are the effects of carbon dioxide and aerosols different in terms of climate change? Both contribute to climate change, but how are the effects different? That we will also discuss. So coming to the aerosols, these are just suspension of fine solid particles and liquid droplets in air or another gas. The condition is that they have to float on the air. They cannot just be so heavy such that they drop from the atmosphere and settle on the ground. So they have to float. That's why they are called the suspension. And they, due to their very small size, they are invisible to the human eye. I think you have some question, one question in the assignment comparing the size of the aerosol to the width of a human hair. So it might be, I don't know, 1/10 or 1/5, whatever. It is very small. Now, for examples, we actually are habituated to aerosol. We often use the spray or the fragrances to produce good smells. These are actually aerosols. They are also known as atomizers. And the natural aerosols include the fog, which we see in the cold weather, or sudden drop in temperatures. Mist. Mist is little different from fog. So, but these are also aerosols. I don't exactly know the difference, but yeah, they are also aerosols. And dust from soil. So we cannot see, but if the wind blows through the fields or the barren land. They pick the dust from the soil, and they also float in the air or suspend. They are also suspended in the air. Now we have also produced a lot of aerosols. Perfume is the basic one, which is not that harmful, but dust from the industry, different chemical aerosols, that these are very harmful in terms of environmental concerns. And smoke we always produce, so especially from the automobile or the vehicles produce a lot of smokes, and particulate air pollutants. So there are different measurements for suspended particulate matter. So now we talk a lot about AQI, air quality index, this type of things. So they include the amount of aerosols, different aerosols. Now, broadly, we can divide by composition into 6 types. One is the sulfate aerosol, which is nothing but which originates from sulfur dioxide from burning of oil and coal, because they contain sulfur in small amounts. Nitrate is actually an indirect aerosol. So nitrogen oxides form from the vehicle and power plants, and I think a bit it is also present in these fuels. And the general formula is NOx, where X can be 1, 2, uh, 1, 2, or N2O3, like that, maybe 3/2 or 5/2, like that. So NOx is the general notation for nitrogen oxides, or yeah, even N2O, nitrous oxide, which is a greenhouse gas. Yes. So black carbon or soot, these are formed due to incomplete combustion of carbon. So if carbon is completely exhausted or completely oxidized, then it will produce carbon dioxide, because carbon has a valency of 4. So for complete utilization of its valency, it will produce carbon dioxide. But if there is incomplete combustion, then there will be black carbon or soot, which will be black in color. Organic carbon, also from burning fuels and biomass. And there comes the mineral dust, which is natural, of course, natural. It is formed by the sand or soil interaction with the wind. And another aerosol type is the sea salt, which are found in the oceanic regions or sea regions, which are generated by sea sprays. Now, sea sprays is that in the ocean, often the wind is quite harsh, and due to that, it produces a lot of foams, a lot of waves, and from that, the tiny particles of the sea salt, calcium chloride, magnesium chloride, sodium chloride, this type of elements are mixed into the air, and as they are very small, they float and they are suspended in the air. So these are broad classification of the aerosols in the atmosphere. Now, in this picture, we can see some aerosols. This is taken from NASA. I think, yeah, I mean, here the link is mentioned about Wikipedia, but this picture, I think, is originally from NASA. Here we can see different aerosols. So now I would just ask you that, can you identify the aerosols, different type of aerosols? So just check. I will ask Vadari Satya, are you here? Vadari
Yes,
Satya?
sir.
Yes. So can you please cooperate us with identification of the aerosol types? Can you tell me which type, let's say, which is corresponding to the dust aerosol in this picture? Which color? There are actually 4 colors, as we can see. One is this yellowish color, another is this green color, the third one is the blue color, and the fourth one is the white color. Okay. So from there you have to identify the type of the aerosols. So that is available in Wikipedia, so you can easily go to the link and identify, but I'm just asking whether you can guess or not. Okay. Anu Dafi, are you here? Okay. I will ask Ankit Mukesh then. Ankit Mukesh, you're here.
Yes, sir.
So can you please identify the smoke aerosol from here? Why? What can be the smoke aerosol? Which color?
Orange or yellow, sir?
Orange or yellow? Okay. But what is this region? Can you identify this region where the mouse is pointed? Here in the North Africa, what is there?
हिंदी में एक्सप्लेन कर दो सर.
या आप बताइए ये इस इलाका में क्या है? यहाँ क्या है? रेगिस्तान है या क्या है? आप बताइए. Is there any desert or something? आपके पास ये सवाल है. आई एम आस्किंग यू दैट व्हाट इज हियर? यहाँ क्या है? Is there desert, रेगिस्तान or green land? हरियाली? That's what my question is. So here is Sahara Desert, okay? So due to Sahara Desert, there are a lot of dusts in this region. So this correspond to the dust, and this, you can see the white color, this correspond to the smoke, and this blue color, you can see, these are formed in the oceanic region, so they correspond to the
Right.
sea salt, okay? And apart from that, these green colored aerosols, they correspond to the sulfate aerosols. Let me just jump to the Wikipedia page. So there is the picture here. Okay, let me just check. Okay, yeah, sorry. So green is the smoke. Green is the smoke. Uh, Blue one is the salt, okay? And yellow one, yellow orange, that is the dust. And the white one, that is sulfuric, or this is also known as sulfate aerosol. So these are the four major type of aerosols that are found in this region. Due to the presence of the desert, there is high amount of dust present. So here you can see that Arabian desert, there is the Sahara desert, and here is it, on the western part of India and some part of Pakistan, there is also our third desert present. So due to the desert, there is dust aerosol. And C1 is quite straightforward because the oceans are there. So there will be blue aerosol, which is okay. Okay, I will just explain in Hindi once. So समुंदर के आसपास ये नीला वाला जो है, that will be salt aerosols, नमक का जो aerosol, okay. And dust aerosol, जहाँ रेगिस्तान है वहाँ ये धूल का aerosol वो मिल जाएगा आपको. And then comes the green for smoke. So these regions, they produce a lot of biomass activities. So यहाँ काफी हरियाली है. It is I think Amazon forest. So and here this area is also, there is a desert, Kalahari desert, but this area is quite green. So they produce the smoke aerosol, and white aerosol is the sulfuric acid और द सल्फेट एरोसोल. ये जो सफेद है ये वाला आपका सल्फेट एरोसोल जो है, ये कारखाने में जो पैदा होते हैं उसके लिए इसका उत्पादन होता है. It is produced. So you can see in the East Asian region. So this is Chinese area, okay, the region of China. So they produce a lot of these dusts, or sorry, lot of sulfuric aerosols or sulfate aerosols from the factory industry. Similar things can be seen also in the East region of United States of America. They also produced a lot of white or sulfuric aerosols. From the patterns, you can understand which are the part of these aerosols, and they are basically heavy in biomass. So यहाँ काफी हरियाली है, तो इसके लिए हमें स्मोक एरोसोल को देखने को मिल रहा है. सो ये पैदा होता है कि ये जो पौधे हैं उसको जलाने के लिए बहुत कुछ पैदा करते हैं. They are produced due to the combustion of these plants, etc. Because this is dense in forests, similar to this region. So yeah, just a rough idea of what type of aerosols are present in the different regions. So yeah, please ask for any query. Is it fine, Ankit Mukesh, or I shall explain in again in Hindi, or is it fine? Okay. So yeah, any queries? I think you have a similar question in the assignment, so I just put this plot map here. Arjun, any question?
No, it's fine.
Okay. Yeah, these are just descriptions of aerosols. Now, one thing I should mention that wherever you see white aerosols, it means that it is reflecting a lot of light. So these are sulfate aerosols. That's why the reflectivity is white, or I'd say they are scattering aerosols. So the scattered light is very high. So you can see them as white colored. Okay. Otherwise, you could see a different color. And yeah, I mean, these sea aerosols are also very reflective in nature. So the sea salts also show whitish color, but they are into the ocean. That's why they show this bluish color beside them. So we will now discuss a bit about some types of the aerosols. First, we will discuss about the surface aerosols. So where are sulfate aerosols formed, that we will try to discuss. Uh, okay, we'll just yeah. So Ankit Mukesh, if you face any difficulty in understanding, just let me know. I will repeat again in Hindi probably. Okay.
Okay, sir.
Just I am going through this. Just feel free to stop me at any point of time. So yeah, in sulfate aerosols, how are they produced? So the first topic is the production. So they are present in the coals, natural gas, or petroleum products. From there, sulfur is present, and from sulfur, sulfur dioxide is made. That is anthropogenic because we are extracting those fossil fuels since long. And there is a debate actually. There is a debate that sulfur aerosols, they can reduce the absorption of the sunlight. So if we are extracting fossil fuels, then we are also producing a lot of sulfate aerosols. So why are we not cooling the planet, or are we really cooling the planet? So there was a debate on that. Now the case is that due to carbon dioxide, the planet is warming due to greenhouse effect. Due to sulfate aerosols, planet might cool a bit, but the effect of carbon dioxide is far more strong compared to the cooling due to the sulfate aerosols. So eventually, in total, we are basically increasing the temperature or increasing the greenhouse effect. Anyways, just a point. And lifetime, that is very important for this type of aerosols. Any questions? Okay. So lifetime. So these aerosols, the characteristics of these aerosols is that the lifetime of the aerosols is very low. So at most they can be present up to 1 week in the troposphere. And in the stratosphere, of course, there are no involvement of water vapor or this atmospheric activities, weather activities. That's why they can stay there up to 1 year in the stratosphere. And before returning to the ground, so maybe in the period of 1 week in the troposphere, they can influence the climate, at least locally. So they will not influence it globally, but they will influence locally. So on 1 week, they cannot fly far enough. So they mostly would be limited to that region in which they are originated. Okay. So because the wind speed is not enough in 5 days to cover the whole Earth. Anyways, so what they do is they reflect visible light into the space. Because of their properties or their structures, chemical properties, they reflect the visible light a lot. And they, of course, allow the infrared light to pass through. And that's why overall they have a cooling effect. And so also they have another effect, that is they are hygrophilic, hygrophilic, or uh, they actually love water. That is the meaning of that. So they can provide nucleation sites for forming cloud droplets. Now, if they form a lot of cloud droplets, then the reflectivity of the clouds will also increase. That's why, in a both way, one is the direct reflection of the solar radiation, another is the indirect reflection via developing the clouds. That also help increasing the albedo. Okay, so that's why this causes the global cooling. So this is also known as global dimming. So it is opposite of the global warming. So due to this property, a proposal was there, or it is still under consideration or under research, that if we can inject a lot of sulfate aerosols in the stratosphere, they will be there for 1 year or so. We can reduce the temperature, which we have already damaged, which we have already raised due to the global warming. But there are risks associated to that, especially because of the reaction of the sulfate with ozone. They might cause the ozone depletion. So we will be in a greater danger compared to the present difficulties. And they can
Excuse
also,
me,
yes,
what is global dimming, sir?
yes, I will explain, Yes. Just let me complete that. I will explain the thing in Hindi, okay?
Okay, sir.
Now that's why they have introduced stratospheric injection of sulfate aerosols, which you will often encounter as global solar geoengineering to reduce the global warming. But we have discussed that this might cause ozone depletion and stratospheric temperature change as a result of uh, this reaction of the sulfate with the ozone layer, and also the uh, increase of the radiation in the stratosphere, because it can cool the troposphere, but it can warm the stratosphere. So there might be different effects of this stratospheric injection. So yeah, now global dimming. Yeah, I've just explained in okay. So if there, I think you understood the global dimming, Arjun, is it fine?
Yeah, it's fine. It's
So
fine.
I will just explain. I will just ask, but Daddy Satya Kumar, you have understood the global dimming? Because I will just explain the same thing in Hindi once. Okay, I hope he has understood. So yeah, so yeah, तो क्या होता है कि हम बोले कि लाइफ टाइम ऑफ सल्फेट एरोसल्स इज 1 वीक इन द ट्रोपोस्फियर. सो इसका समय सीमा जो है वो कि 1 हफ्ता है. 1 हफ्ता तक ये सल्फेट एरोसल्स वातावरण में रह सकता है. उसके बाद वो नीचे गिर जाता है या फिर विक्रिया कर देता है दूसरे पानी जो भी हो उसके साथ. देखिए वाष्प जो भी. तो उसके पहले वो जो सूरज से आने वाली जो आलोक है उसको वो प्रतिफलित करता है, रिफ्लेक्ट्स द लाइट इनटू द स्पेस. और प्रतिफलित करेगा तो क्या होगा, द एल्बिडो विल इंक्रीज, एल्बिडो का परिमाण बढ़ जाएगा. बट इट अलाउज द इंफ्रारेड लाइट विच इज हीट वेव्स टू पास थ्रू. मतलब जो ताप का विकिरण है वो तो वैसे ही चला जा रहा है, तो उसका कोई प्रभाव है नहीं. एक तरह का प्रभाव हो गया. दूसरा प्रभाव क्या हुआ कि न्यूक्लिएशन साइट्स फॉर वाटर इनटू क्लाउड्स, बादल पैदा होने के लिए एक छोटा छोटा जो कणिका चाहिए वो पैदा कर देता है सल्फेट, क्योंकि उसको आवर्धित करके बादल बन सकता है, छोटा छोटा पानी का बूंद एक साथ एकत्रित हो सकता है। तो ये प्रतिफलित कर, ये भी मतलब बादल जो बना वो भी प्रतिफलित करेगा सूरज से जो आने वाली किरण उसको, और इंफ्रारेड ऐसे ही पास कर जाएगा। तो तो इसका क्या हुआ, इसका प्रभाव क्या हुआ कुल मिला के कि ये जो वातावरण है ट्रोपोस्फियर, जो हमारा ट्रोपोस्फियर है, वो ठंडा हो जाती है, क्योंकि जो आने वाली किरण है वो आ नहीं पा रही है, और जो जा रहा है वो ऐसे ही जा रहा है, तो उसमें कोई बदलाव है नहीं। तो इसके लिए ग्लोबल डिमिंग मतलब जितना सूरज का किरण आपको प्राप्त होना चाहिए था उससे कम सूरज प्राप्त होगा। डिमिंग मतलब डिम हो जाना, कम हो जाना। इसके लिए इसको ग्लोबल डिमिंग बोलते हैं। इसको सोच समझ में भी रखे हैं लोगों ने, कि वैज्ञानिक ने, कि इसको हम जो ग्लोबल वार्मिंग है, जो धरती का तापमान बढ़ रहा है, उसका विरुद्ध हम क्या उसको इस्तेमाल कर सकता है या नहीं नहीं। तो यही सोच है, पर इसका बहुत सारा अ, क्या बोले इसको, डिफेक्ट्स, एडवर्स इफेक्ट मतलब दिक्कत है। तो दिक्कत है कि ओजोन डिप्लीशन, ओजोन जो स्तर है उसको ये इसके साथ विक्रिया कर सकता है, उसको चोट पहुंचा सकता है। और दूसरा है कि स्ट्रेटोस्फेरिक टेम्परेचर चेंज, तापमान जो है स्ट्रेटोस्फेयर का उसमें भी बदलाव ला सकता है, तो वो पूरा धरती के लिए अच्छा नहीं है। जो कृत्रिम है वो धरती के लिए अच्छा है नहीं। इज इट फाइन?
Actually, if we inject sulfate aerosols in the layers above the stratosphere, would it reduce global warming?
No, the problem is, will it stay on the layers above the stratosphere? The atmosphere is so thin above the stratosphere, right?
Oh, okay, okay.
So due to the buoyancy effect will not work.
We go in outside.
Yeah. Ankit, Mukesh, is it fine?
Yes, sir.
Okay. Oh, this photo has very low resolution. Anyways, just picked it from. Anyways, so just they have shown the emission of the sulfate and the effect of that. So here they have just shown that the sulfate is emitted, sulfur dioxide is emitted from the factories, and from it undergoes photoreaction, means reaction with the presence of the light. And in urban areas, they are producing small sulfate aerosols in the troposphere. These are pure sulfate aerosols, and on the other hand, they are also forming the clouds. बादल पैदा कर रहे हैं. Okay, ये मुक्त थे, ये ऐसे ही विचरण कर रहे हैं, ये बादल पैदा कर रहे हैं. So they are free here and they are producing clouds here. And there are different reactions. I also don't even the reaction properly, but they have shown the reactions, and they eventually lead to the sulfate ion, which is actually the sulfuric acid ion. H2SO4 is the formula for sulfuric acid. And from there, they can decrease the pH, or they can basically make the water more acidic. So that is the conclusion of this. So just to elaborate, just to illustrate the sulfate aerosols. Okay. So now comes the second point of black carbon aerosols. These are also another important. So the sulfate aerosols are primarily reflecting aerosols. So they tend to cool the temperature. They can mitigate the problem of global warming, though there are side effects. Black carbon aerosols are different in nature. Due to the carbon structure or the blackish appearance, they mostly will absorb the lights, and they are produced by incomplete combustion of hydrocarbons. Lifetimes are mostly the same, so a few days to a few weeks, and it warms the earth. Okay. On contrary to the previous case, it warms the earth by absorbing sunlight and heating the atmosphere. Because it is black in color, it will absorb most of the solar insolation, and it will reduce the albedo. Also, when it will deposit on snow and ice, because ice and snow have very high albedo, in between, if there are black patches, it will decrease the albedo. So it supports the global warming. But there is a subtle difference while the black carbon aerosol will be above the cloud or below the cloud. There is a question based on that. So above the cloud, there will be some effect. Below the cloud, there will be some other effect. We will discuss that later. And it is also PM 2.5, so particulate matter which has diameter less than 2.5 micrometers. Okay, and they can cause respiratory diseases. So we discussed about the effect of aerosols on human health. Now we cannot see some aerosols which are also less than 2.5 micrometers in width or in diameter. So they can enter our lungs or our respiratory systems, and they can affect those systems. So they are also dangerous to the cardiovascular diseases. However, they are not dangerous to the climate, but if they are larger in size, then they will not affect our cardiovascular system, but they will affect the climate system. So these are differences. Now, approximately 20% of the black carbon is emitted from, these are the statistics, burning biofuels, 40% from fossil fuels, and 40% from open biomass burning. So yeah, it is mostly anthropogenic. Natural sources are there due to volcanoes, but mostly this is anthropogenic or human-made. Okay, I listed a few region. Okay, Indo-Gangetic Plain, the river Ganges, Eastern China, Southeast Asia, Mexico, Peru, Brazil, Equatorial Africa. So there are a few regions which produce a lot of black carbon aerosols. By the way, in India, there are diverse aerosols present in the different areas. For example, in the coastal area, we will see sea salt aerosols. In the northwest India, close to the Rajasthan or surrounding areas, we will see dust aerosols. In the Ganges plain, we will see this black carbon aerosols. And there will be also industrial hubs where we can see the sulfate aerosols in the Indian region. So, and during the time of monsoon, the aerosols will be suppressed. So the value, the number of aerosols or the density of the aerosols will decrease during the time of monsoon. Okay, so I will ask for any queries about this black carbon aerosol because it is an absorbing aerosol, not reflective. Ankit Mukesh, is it clear or I shall explain again?
Yes, sir.
Clear or explain?
Yes, sir. Clear, sir.
I shall go on, right? Or you understood the black carbon aerosols, is it? Or you have some doubts?
No, sir. कोई डाउट
Oh,
नहीं है.
okay, okay, fine, fine. Yeah. So Arjuna ji, is it clear?
Yeah, it's clear. It's clear.
Okay. Now the only difference in the black carbon aerosol, the only complication in black carbon aerosol is that it might be positioned above the cloud or below the cloud. Now these two will have different effects. And also, yeah, there is another complication of ice cloud effects. So warming all or cooling, they're not equivocally saying warming or cooling anyone. They are saying that this both can contribute. Now, mixed phase cloud effect, they are telling that net warming from black black carbon nucleation effects and surface warming by black carbon deposition. Due to mid-latitude snow, of course, if it is deposited on snow, then it will decrease the albedo, so then it will warm the surface. That is clear. Now here, just look here. Liquid cloud effects, net cooling from BC albedo, lifetime and semi-direct effects. So the lifetime effect is that if the lifetime of cloud is somehow increased, then it will basically reflect the sunlight because if there are more clouds, they will reflect the sunlight. In fact, due to the presence of the clouds, our albedo is higher than what it should be without cloud. So under cloud-free Earth. So, but they provide nucleation sites for formation of clouds. So they cause the net cooling though they are black in color, they cause net cooling in terms of forming the cloud. Okay, that is one effect. Now here they are telling the net warming for VC nucleation effects. Then they are telling it is causing warming because if somehow the black carbon aerosol is present above the cloud, then it will absorb the solar energy. Also, it will absorb the reflected sunlight from the clouds. So that will cause warming. If it is present below the clouds, then it will cause cooling. It might cause cooling. So yeah, because of these complications, it is very difficult to say what the total effect would be. Anyways, the modeling of cloud is a very difficult task for Earth system. But locally, taking into consideration all the effects, it causes warming. So it has similar effect to that of carbon dioxide. The only difference is that it is limited to the region where it is formed. It cannot travel globally or worldwide. And now the third type we are discussing is the nitrate aerosols. So in the nitrate
Um,
aerosols,
uh,
yes,
I don't know if you can answer this because it's part of the assignment, but how does aerosols below, black carbon aerosols below clouds lead to negative forcing?
if the black carbon aerosol is present below the, so yes, below the cloud, then point number one is that the reflection, suppose some solar radiation had to be reflected. If the aerosol is present below the cloud, so this is cloud, this is aerosol. Now, if it is reflected, then the cloud does the job. Reflection is done. It is already reflected. If the black carbon aerosol was not there, then the total radiation would reach the earth, anyways, the earth's surface. So, first case, it will not affect zero warming effect. Second point, it can contribute to accumulate the cloud droplets. If it is below cloud droplets, it can contribute to accumulate or gather the cloud, and gathering the cloud, increasing their lifetime, increasing the surface area because it provides a platform for nucleation. So increasing the surface area will again increase the albedo of the cloud. So if the albedo of the cloud is increased, then the temperature will decrease because the absorption is less. I understand it that way.
Okay.
Yeah, this is just my explanation. I don't know whether it is correct or not, but I understand it in that particular way. If black is above the cloud, then it will cause warming. If it is below the cloud, then it will at least not cause warming. The benefit is it might cause cooling. So that is how I understand.
Okay. Okay.
Okay, so yeah. So for nitrate aerosols, yeah, they are caused by vehicle emissions, biomass burning, emissions from oil and chemical industry, ammonia from agriculture because they can produce ammonium nitrate, and farming produce nitrate aerosols. So one important point to note that they are secondary pollutants from NOx. So NOx doesn't directly cause the formation of the aerosols, but the side products or the secondary products which is built upon the reaction of NOx with the atmosphere or different substances in the atmosphere cause the form the nitrate aerosols. Okay. NOx reacts with different components in the atmosphere, and that's how they form the nitrate aerosols. The lifetime is relatively short, 3 to 4 days, and then they are deposited on the surface of the earth. So it is again a local effect. Wherever nitrate aerosols will be there, the regions close to that will be affected. They are scattering aerosols, so they contribute to the cooling of the atmosphere. So they scatter most of the rays, most of the lights. That's why they have cooling effect. So they are also part of the PM 2.5 because if you look at the air quality index, there will be a separate index for NOx. Okay, I think I have a nice website for that. Anyways, I'll just open it for the fun purpose. Let me just check. And nitrate aerosols have hygroscopic property. It means hygroscopic means it attracts water or it loves water. So it will accumulate those water or stock those water, store those water and make cloud droplets. And they can also efficiently scatter the solar radiation. Okay. So I will just open a site called Windy where I might see some current situation of the aerosols. Just let me check. Oh, windy. Now it is the month of March, so it is very dry in most of the regions on Earth. So I don't know whether I will find it or not. Oh, clouds, air quality index. Oh, okay, that's great. Okay, let's go to the sulfate. Okay, first go to the nitrate, then we will go to the sulfate. Now here is the PM 2.5. So you can see PM 2.5 position. So that you can see the screen, right?
Yes.
So yeah, in the Gangetic Plain, there are a lot of PM 2.5 present in these areas. And there is the Tibet region, so Himalayas, Tibet region, so there is very less value of the PM 2.5, but otherwise in the other regions there is very high value of PM 2.5. Yeah, in oxide. I'll just go to nitrogen dioxide. So yeah, you can see that this is very close to Delhi. So it is we already know that it is very polluted area. So you can see the high value of nitrate aerosols or nitrogen dioxide in this region. And the whole Indo-Gangetic plain is present. Relatively West India is safer. And there are some present in the South India. And sulfate aerosols. Sulfate aerosols, yeah, there is a big accumulation of sulfate aerosols in the eastern India. Um,
ये क्या करता है सर?
yeah, yeah, जी,
जो आपने ये स्क्रीन पे मैप दिखाया, ये क्या शो करता है?
अच्छा, ओके, ये विविध चीज दिखा रहा है। यहाँ हमें NO2 डाला तो नाइट्रोजन डाइऑक्साइड या नाइट्रेट का परिमाण दिखा रहा है। PM 2.5 मतलब छोटे छोटे जो कणा होते हैं उसको दिखा रहा है। SO2 मतलब सल्फेट, हम जो चर्चा किया सल्फेट एरोसोल के बारे में, वो दिखा रहा है।
ओके सर।
Windy, it is a very useful website. You can also try windy.com. So, dust mass. Now, see for the dust mass, you can go to the see here in the um, desert area. You can see a lot of dust mass, right? Because the dust aerosols are mostly produced through the desert. You can see the dust mass is not very high in India, but it is very high in the Sahara Desert, Arabian Desert in Africa. Yeah. Anyways. What else? You can see also air quality index here. So due to aerosols in the Arabian region, the air quality is very poor currently. I mean, India, the air quality is okay, not that good, but also not that bad. And wherever there are less human intervention, the air quality is very good. See the example of South Indian Ocean. The air quality is very good. It is green here. And so, yeah, these regions are bad in air quality. Just look into US, the air quality is very good in the most of the United States of America. So they worked a lot about the sulfate aerosols earlier. So we are still in the developing stage, but they reduced the amount of sulfate aerosols in those regions. So the sulfate aerosol was quite. Oh, here they are showing the aerosols, but I don't know what aerosols they are showing here. Okay, AOD. AOD means aerosol optical depth. Okay, fine. Optical depth means how hazy is the sky or how clear is the sky. Higher optical depth means the sky will be hazy. Lower optical depth will be the means that the sky will be clear from the aerosols. Anyways, so that was a map showing different parts. Let's close it. So next we will go to the, okay, there is a reaction chart present in the current slide. Here they are showing how nitrogen dioxide and different nitrate oxides are formed. Nitrogen oxide, nitrogen dioxide, nitrogen trioxide, nitrogen pentoxide, and during daytime and nighttime they are formed. In the daytime, they form a substance called photochemical smog, which is very harmful for our health. So the just H nu means the daylight or the sunlight present. From that, many reactions happen. Oxygen to ozone also happens here. We have also shown that. And from nitrogen, I think NO means nitrogen oxide. It forms nitrogen dioxide. At night time, it forms nitrogen dioxide. And if I find, you can just read the slides later. Now, how photochemical smog is produced is given here. Due to the solar radiation, the from the nitrogen dioxide, different substances are present. Different substances are formed. One of them is nitric acid, PAN. PAN means what was the just check. Peroxyacetyl nitrates. Okay, fine. Peroxyacetyl nitrates. So they form the peroxyacetyl nitrates and aldehydes present here. And with the reaction of nitric acid with ammonia or different aldehydes, hydrocarbons, they form that photochemical smoke in the presence of light, of course. And this is very harmful to human activity. So this is the negative part of the nitrate aerosols, so they are present in the atmosphere. Yeah. Okay, so now we will go to a few math questions related to the assignment. So absorption and scattering aerosols. Aerosols have both absorption and scattering effect. On the one hand, they can scatter the light. Scatter means no absorption of light or no absorption of energy. So they will just redistribute the light in different directions, and they will not cause any change in the wavelength of the light or the color of the light. Let's say there is an intensity of I lambda, which is incident on the medium, which is the depth of dx or the length of dx. If the now just forget about the constants for the time being. The di lambda will be proportional to I lambda. So if we give more intensity, the loss of intensity will also be more. And it is also proportional to the length of the medium dx. If the medium is longer or it travels across longer path, okay, so the decrease in the radiation will be also more. So if it transmits through longer path, then the decrease in the intensity will be more because it will continuously lose the radiation. In order to maintain the proportionality, we have added the proportionality constant A lambda plus sigma lambda. This is called the attenuation coefficient. So A lambda is known as the absorption coefficient and sigma lambda is known as the scattering coefficients. Now if absorption coefficient, what it does is it absorbs the light and increases the energy level of that particular molecule. Suppose the light is given, if absorption is only happening, then it will just absorb the light and some light will be passed, some light will be absorbed. For the absorbed light, it will increase the level of energy present in the molecule. For scattering, it will not absorb anything, but it will redistribute the light in different directions. Suppose it was coming through an angle of 0 degree, which is the incident angle, it will distribute all the energy from let's say 0 degree to 360 degree, or plus minus 180 degree with some functions. It might be cos function, it might be some inclined function towards the forward or backward direction, mostly in the incident direction or the direction of the light. So that is the incident, or that is the phenomenon of scattering. But in both cases, the intensity in which in the direction of the incoming light will decrease, and the decrease will follow that formula. And if you integrate that, you will find an exponential solution. I lambda equals to some I naught lambda times e to the power minus alpha lambda, a lambda plus sigma lambda times x, something like that. Now for the scattering albedo, the single scattering albedo is defined as the scattering part divided by the total attenuation part. So how much is scattered with respect to how much is totally attenuated. That is the single scattering albedo. Now you can look at it using two cases. If sigma lambda is 0, so it is not scattering, it is only absorbing, then the value will be 0 because it is 0 divided by a lambda. So that is the case for completely absorbing aerosol. There comes another case in which sigma lambda is very high and a lambda is very low or close to 0. In that case, sigma lambda divided by sigma lambda plus a lambda, that will be almost equal to 1. That means whatever is incident on that particular molecule, most of that is scattered. It is not storing anything in the molecule. So it defines how good a scatterer or a scattering aerosol is. Sulfate aerosol, of course, has higher value of sigma lambda, and black carbon aerosols have lower value of sigma lambda. A lambda is high. Now, the first question is, a type of aerosol has sigma lambda equals to 5x and a lambda equals to 3x. Now, what is its single scattering albedo? Okay, someone has messaged. But that is Satya Kumar. Can you please share the PDF? I want to write down the important points in my notebook. The PDF will be shared in the folder that you already have got. I have not uploaded that. After the lecture, I will update that in the PDF. So there is a folder. I think you have access to that. Every week's lectures or every week's presentations are maintained in that PDF. Okay. So you will get that. Maybe within 40 minutes, 40 or 50 minutes, you will get it.
Actually, what is the difference between albedo and scattering? Is it the direction, or what is the main difference between albedo and
It is
scattering?
the direction. Yes. So because they have defined the single scattering, they have defined the two terms, single scattering albedo. That is the term. So the direction in which the light is going, whatever is coming out of that particular direction, I think that is how they defined the single scattering albedo. Albedo means, suppose you have given something and on a particular direction, because light goes in a straight way, and you are looking at how much of it is coming out of the substance or the surface, right? And scattering means that how much of it is eventually, if you integrate over the whole surface, how much of it is coming out, right? So in scattering, it distributes the energy in all the directions,
Okay.
and albedo is a no, scattering is a phenomena, right? And albedo is a measurement. So the phenomena is called the scattering.
Okay.
Albedo is whatever you are giving and whatever is coming out of that, the coming of the outgoing divided by the incoming, that is the albedo. And for scatter,
Is it possible to derive the albedo of a substance or something
of
like?
course, why not? Albedo is just the outgoing divided by the incoming, right? So you can derive the albedo using.
Like for example, the cloud is the single scattering albedo. What is the relationship between single scattering albedo and like albedo of clouds? Like, what is the difference? I mean,
Just let me think. Yeah, the thing is that scattering and reflection, they are two different phenomena. Now,
okay,
scattering,
reflection doesn't change wavelength, is it? Or
no, scattering also doesn't change well. Reflection,
okay,
reflection means whatever you are giving, the raw of reflection, right? The incident and the what it say,
reflect wave.
reflected angle I and R, both are the same for reflection. And
Oh,
in reflection, the in general the intensity of both incoming and reflected light, they are the same.
same.
For albedo, what it will sorry, for scattering, what it will do is primarily it will maintain higher intensity in the incoming direction or the direction of light. Okay, and
Okay.
it will distribute the whole light in different. I will just show you a picture. Let me just check. I can place this. Uh, Just
Also, scattering have different types. Is it like me scattering, Rayleigh scattering, and so
right, right. I had a slide from hyperpixel with this thing. Just check. So the distribution of energy matters. So that's why. Okay, it is loaded. Yeah. So yeah, for example, here they have mentioned about the Rayleigh scattering. So you can see that the incident light is in that particular direction, and the scattered light is
all direct.
distributed on all the direction. If it was reflection, then it would have only one direction. So that is the difference between reflection and scattering. And there is another scattering called Mie scattering. In Mie scattering, the intensity in the forward direction, which is the forward direction, is very high compared to the
Okay.
intensity in the side direction. But I also would like to know that, yeah, because scattering, I would state it in a way that scattering is a part which contributes to the albedo. There are reflection also which contributes to the albedo. So
Right.
reflection is one part, scattering is another part, absorption is the part which is, I mean, basically decreasing the albedo. So the combination of these three. But yeah, if you want to measure albedo, I think the simplest calculation or very clean calculation will be take the incident, take the outgoing, and measure the ratio
Divide.
between the outgoing and incident light. So that is the albedo. That might be due to reflection, that might be due to scattering. If it is due to scattering, then the possibility is that the rays will be trapped in the medium somehow, and it will not be able to get out of that. While
Okay.
while
Okay.
in the reflection, it will just pass. I mean, it will not enter the medium. That's how I think it will happen. But yeah, satellites, if you measure the albedo from the satellites, it will just see, because it is in the space. So it will just measure the radiation that is coming out of the Earth.
And
It
into
doesn't know whether it is due to scattering, whether it is due to reflection, whatsoever. Whether it is due to ground emission, it doesn't know. It just knows that whatever is coming out in that particular wavelength.
Okay.
Yeah, so the calculation is very simple. Now, yeah, just a sigma by sigma plus A. That is defined as the single scattering albedo. So on the first case, it is 5x divided by 5x plus 3x, which is 5 by 8. Is calculation correct?
Yes, I will.
0.625. Okay, cool. Now, second question is the same question, just I have changed the values. And yes, we should mention the wavelength in which it is absorbing or scattering, because it is a function of wavelength. So at a particular wavelength, it might scatter more. Another wavelength, it might scatter less, absorb more. This is the
Okay.
difference. So yeah, in the second case, it is just 2x divided by 2x plus 8x, which is nothing but 0.2. Now, if you question what is the effect of black carbon aerosols on albedo, so black carbon aerosols decreases the albedo, and sulfate aerosol increases the albedo. What is the effect of sea salt aerosol on the formation of cloud droplets? First of all, sea salt aerosol is a very highly reflective substance, so it has a very similar effect to that of sulfate aerosols. So yeah, the scattering is very high, or the single scattering albedo is very high for the sea salt aerosol, same to the sulfate aerosols. So they will at first they will reflect the sunlight a lot. Secondly, they will try to gather the cloud droplets because they are hygroscopic, so they can attract the water, because yeah, the water can dissolve salts very easily. So it can also provide nucleation sites for the salt. So for the water. So sea salt particles can form cloud droplets and increase the lifetime, because if the sea salts have higher lifetime, then the clouds will also have higher lifetime. And they will increase the reflectivity of the clouds, because if there are more cloud droplets formed, then the surface area of the cloud will be increased. Due to that, the reflectivity of the clouds will also increase. So that is the question. Yeah, there are a few questions. I will just go through that. For that, I will just ask in them. Okay. Yeah, I will this time ask Priyanka Nimran. Are you here?
Yes, sir.
Okay, so did you understand the problem, the question in which we have to measure the single scattering albedo? Or shall I repeat? Okay, I guess that. Yeah, please let me know if anything is left, because we don't have much materials for today, so you can just repeat also. Yes. So now we will deal with some questions on aerosols. First question is, how can absorbing aerosols above the cloud decrease the overall albedo? So they can absorb incoming solar radiation, and the radiation from the clouds below them. In the both cases, they will increase the absorption of the solar light. So they will warm, they will increase the temperature of the troposphere, the whatever levels the aerosols are present. If they're below the cloud, they will decrease the overall albedo. So they can enter the cloud, and smaller cloud droplets will be formed, and that at first they can increase the lifetime of the clouds at first. Secondly, they can also increase the surface area of the clouds, that will eventually increase the reflectivity, because from the top of the clouds the reflectivity is very high. we see a satellite image of any clouds, we will see that the reflectivity of the clouds is very high. So that is confirmed. Now the third question comes, state the type of the aerosols mainly affecting the regions East Asia, North Africa, and marine regions. So in East Asia, there are a lot of industries, especially in the region of China. There are a lot of industries, a lot of pollutions. So sulfate aerosols are there, black carbon aerosols are there. Also, organic carbons are there. Though organic carbons are more formed due to the burning of the organic materials, as we saw in the regions of Africa and some parts of South America. And in North Africa, it is undoubtedly the dusts which are formed due to the interaction of wind with the desert regions. And in marine regions, of course, there will be sea salt aerosols because there are plenty of sea salts there, plenty of salty water. So the wave breaking or the sea spray, they can act to increase the amount of sea salt in the atmosphere, and they're so tiny particles that they will be suspended in the atmosphere. Okay, so by the way, I will ask you one question. So it is a general question that these particles, this maybe carbon, maybe sulfate, maybe let's take example of water droplets also. What is the density of water? Can anyone tell me roughly?
1 kilogram per meter cube, right?
1 kilogram per meter cube or 1,000 kilogram per meter cube?
Okay, thousand, thousand, yeah, thousand.
So you
Thousand.
popularly known as 1 gram per cc.
Yeah, yeah.
So if you convert it to kg per meter cube, then centimeter is basically 100 centimeters is 1 meter.
1 gram per centimeter cube.
Yes, 1 gram per centimeter cube. Exactly. So yeah, just you can assume that 1 gram per centimeter cube. And what is the density of air? Rough density.
Actually, it varies
One
according to altitude, right?
Yes, yes, it is according to altitude. Let's say in the troposphere, or let's say 3 kilometers above the ground.
air density 1.225 kilogram per meter cube.
Right. And the density of water is 1,000 kilogram per meter cube, right? 1 gram per cc, you told. That means that it is 1,000 kg per meter cube, right? So now, why do you think that the cloud droplets will stay in the atmosphere for some time? Why won't they fall? What is your reason behind that? Similar things goes for aerosols also. But let's start with water. So water is almost 900 times denser than the air. And cloud means water. Cloud means formation of waters. Then why do they stay in the troposphere or upper troposphere? There the air density will be even less. So why do you think that will happen? So they, in the first place, they are not supposed to stay there, right? They are they are supposed to directly come down. So why do they stay? Why do they form? And after some time, then they start raining. What is the reason behind that?
They circulate, right? Because of wind.
Okay,
Wind
but
elements.
so do you think that the wind is so strong that it can uplift 1,000 times higher in density?
Actually, there is pressure gradient force, right? So pressure gradient force will be greater than weight, so it will move up.
What pressure gradient? This is equal, right? Pressure gradient needs a gradient. So gradient means it has to be the difference in the length. So just take a droplet. It is maybe 1 micrometer in length. So even if the gradient is there, how much pressure difference will be there? It is multiplied by 10 to the power minus 6.
Actually, there is like deep, though dp by dz is equal to minus rho g
That is
x z.
hydrostatic balance.
Oh, okay.
So if your statement is correct, then dz, let's say dz is 10 to the power minus 6
Small.
meter.
Okay, it will be very small.
Okay, no, I mean just calculate. dp by dz equals to rho g, fine. So rho is 1 kg per meter cube and dz is 10 to the power minus 6. So dp by dz is, so dp, basically dp is 10 to the power minus 6 Pascal, let's say. Now if dp is 10 to the power minus 6, then the pressure which will act on the surface, let's say the surface will be even smaller. So it will be very small. So dp is 10 to the power minus 6 Pascal. Now dp times area, you can multiply the area to get the force. That you can equate to mg. Mg means the mass of the droplet. That will be still very less. Right. So there is something else which prevents them from falling. Updraft is one thing, of course, updraft is one thing. But the second reason is their size. They are so small that they encounter a lot of friction or viscous, not friction, but viscous force in the atmosphere. If you calculate, do you know about the terminal velocity?
No,
Okay,
no.
fine. Okay, fine. So just if you throw anything from above, then it will not constantly increase its speed due to acceleration. So at one point of time, due to viscosity, which is opposing force, and buoyancy, which is opposing force, and the weight of the particle, which is a downward force. Due to the interaction of these three, there will be a velocity formed, which is known, velocity will be reached, which is known as terminal velocity. So terminal velocity means you are trying to, let's say you are trying to swim through water, but the water is preventing you from getting very high speed, the drag. Okay, so there is a velocity beyond which you cannot go. So that is the terminal velocity. Now the terminal velocity for this very small particle is very low. So because of that, they cannot just drop down. They only come to the ground when they form bigger structure.
Power threshold.
Yes, yes, they increase, they reach the cloud threshold. That's why the size is important. Why the size is important? Because it provides very low value of terminal velocity. Now you can just calculate the terminal velocity. There is a formula for that. The formula is, I think, 2 by 9 r 2 by 9 r square rho minus c, something like that. I will just search it and let you. Terminal velocity. So terminal velocity has a formula 2 by 9 r square rho minus, it is one terminal velocity, but another terminal velocity is
Buoyancy, is it?
it is buoyancy related. Let's say yes, Stokes law, and from there you can get the terminal velocity. Yes, this one, the simple one. 2 by 9 rho minus rho g r square mu. So the case is that if r is very small, the radius of the particle is very small, then the r square will be very small. Let's say the radius is 1 micrometer, 10 to the power minus 6 meters. So r square will be 10 to the power minus 12 meters square. So that will give you very low value of the terminal velocity. So that will prevent the small droplets from falling down. So that is another cause. Of course, as you indicated, the updraft of the small water molecules also play an important role. So due to the combination of these two, these water droplets don't fall. Anyway, that is valid for aerosols also. That's why small sized aerosols stay long. Large sized aerosols would
Actually,
stay.
viscosity would is dependent on the shape of the substance, right?
Yes, yes,
Even if it
it will depend on the shape of the surface. Of course, it will depend on the shape of the surface, but we are assuming a spherical. in this case.
Okay.
You're telling about the not viscosity, but viscous force when it is integrated across the surface.
Okay. Yeah, viscous. Okay.
Viscosity is a property of the matter,
Yeah.
property of the substance. Viscous force is a function of surface. Yeah, I think I had all these slides for today. So I thought of putting something related to Kyoto Protocol, but I didn't put anything. I thought this was not very important. So yeah, so this was all about today. You can ask me any questions.
Fine, actually, everything is fine.
Okay, fine. Vardadi Satyakumar, do you have any question?
No, sir.
Okay, thank you. You understood the concept of rain droplets staying in the cloud for long while it is small, right? Using the argument of viscosity and the density or size of the particle. Okay. Okay, I will share the PDF for today. Maybe in 30 minutes or so. Okay, you just go to the folder. You have access to the folder, right? Where you can see every week's lecture. Not lecture, but this presentation.
Yes, it's available on the
Okay, fine.
website.
Yes, I will update in 30 minutes or so. Also, the YouTube lecture will be available tonight. So, thank you. So, if nothing, no queries or questions or discussions are there, then we can stop to this meeting.
Okay. Thank you.
Okay, thank you for attending. See you on the next week.
Okay, sir. Thank you, sir.
Yeah, thank you.